Any other AP? Oh, no, but there's these same, because this guy's just chemistry. Okay. But there's these crash course books for every AP.
That we can check out here?
No.
Oh, okay.
I bought these with department money. So you might be able to like go online and find them through Amazon. Some of your other teachers, if you check with your AP teachers, might have them.
My AP teacher.
Okay. But you could go on Amazon. They're about $12 or $13 a piece.
Okay, that's not bad.
So it's not a huge expenditure of money. That's why.
You can also go to the bookstore or not the one in the mall, but kind of by the mall. They have a whole student section with an AP.
I already have the AP book.
Yeah.
I was just maybe gonna get one of these.
So
this looks kind of like nice and like broken down.
On that note, there's 3 weeks until
like Princeton was this freaking big.
Yeah.
yeah. I checked it the other
The
day.
AP battle was only slightly
Yeah.
smaller.
Tomorrow's the 14th and your test is on the 7th of May. So yeah. I'm hoping by the end of the week we might be through this unit, but we're not going to test on it. We're not going to take time to test on it. So.
And are we going to do like the 2 weeks leading up?
We're going to do as much as I can cram in between now and then. I'm going to do my best to get you there.
Because they switched the whole schedule like twice. Everything.
All right, here we go. We are going to calculate the voltage for this. We are then going to create a galvanic cell based on it, okay? So here we go. All right, so calculate the cell voltage for this reaction, draw the galvanic cell for the reduction, and label completely, okay? So we've got, I need to make sure that I'm presenting the screen. It looks like I am. It's just, I don't understand. This just looks weird. Okay. So I need to figure out which side is reduced and which side is oxidized. So I'm going to be going from, here we go, Fe3 plus. I'm going to Fe2 plus. So in order to decrease my charge here, I had to add an electron to make that happen. Does that make sense?
Mm-hmm.
And I keep forgetting the E on iron here. All right, my copper then is going to be giving off 2 electrons. Oops, shoot. Giving off 2 electrons and becoming Cu2 plus. All right. I'm going to need to multiply this guy by 2 to get everything to balance out. So I'm going to go through and do a 2 here, a 2 here, and a 2 here. And then that way, these electrons will cancel out. I want to get in the habit of noting how many electrons I dealt with here. And that was 2 electrons, because that's going to become important in the coming days. Number of electrons. And you are eventually going to be using this N, which you don't know yet, but it's the number of moles of electrons, excuse me. Sorry, moles of electrons. To figure out delta G on your sheet here, you're going to be using this to do negative NFE prime. So you can solve for delta G here and your E prime if you're given delta G. And this is going to feed in, this is going to be number of moles of electrons that you're going to be filling in here. So I'm getting you set up to recognize that this N value is going to be this N value in this equation. Does that make sense?
Mm-hmm.
All right, so we've calculated, we figured this out. We are gaining electrons here, so this one's being reduced. We are oxidizing this because we are losing electrons here. We can also look and find that information. We've got iron 2 to iron 3 here. I can look back in these potential tables here. And here. No, that's iron 3. Hold on. Here, right here. So see right here in this table, this says that I'm going from 2 to 3. I'm going to be at 0.77 here for that one. So 0.7, oops, why did that move? 0.77 volts. And then my copper, normally for like a test, they're going to have a much shorter table than this for you to have to go through. 2 to here. No, that's 2 to 1. Right here. So this one right here is 0.34. Okay. Well, the way I teach it, it doesn't. Okay. So the way she wants you to do it is she wants you to flip the sign on these. The way I do it is I tell you to take the cathode minus the anode. So you need to figure out, okay, this is the cathode, this is the anode. I know that because this is oxidized and this is reduced. I also know that because this is more positive than this value. Okay? So if I take the cathode minus the anode, I have 0.77 minus 0.34, and then I get my value. The way she has it, then you have to like think, okay, which one of these do I need to flip around based on the thing that's up there? Which one of these do I need to flip the sign on this? So I like the way I do it. If you want to go and listen to her video and do it her way, I just think that it's less flipping of things. You know, I don't have to look and go, okay, which one of these is flipped around based on the chart? Well, then I've got to flip this sign and then I got to put it into this. No, if it's just cathode minus anode, boom, you're done. Walk away. So when I do this, I end up with 0.43. So 0.43 volts is what I got, and that checks out with what she got. Okay, so I get the same answer that she gets. It's just that I don't have to go through all of the mess that she went through flipping equations around and signs and all that stuff. Cathode minus anode. Ka, ka. Remember that? You'll be in the exam going, ka, ka. Crazy Lippy.
There go Lippy's kids.
And Lippy's kids. All right, so that takes care of the first part of this, which is calculate the cell voltage for the reaction. Now they want us to draw this galvanic cell. Okay, so I'm going to just take this and put it up here as my answer. We've studied that. We know where we got that answer from. Okay, I need some room down here to draw. So I'm taking this away. You guys know how I got those values. If you don't, you can rewind the video and find out. All right, so now we're going to go through, we're going to draw this. So our galvanic cell, I always like to, and it's not a requirement, but it just works better in my brain just to have this always on this side, okay? I always put my anode over here, and I put my cathode over here. It's just what I do. Okay, it's alphabetical order. It just works for me. So I've got my cathode over here. I've got my anode over here. Now I've got to figure out which one of these is my cathode and my anode. Well, whichever one is reduced is my cathode. And you can remember that because these are both consonants. Okay? Or you can remember red cat. So in your car battery, the red one is your cathode. That's where your reduction is going to happen. Red is reduction. Okay? Your oxidation then is going to happen at your anode, and that's going to be, these are both vowels. So or you can remember an ox and a red cat. Okay? Oh, I'm yawning again. I cannot stop yawning. Apologies. All right. So what we need to do here then is I need to get a situation where I have my my anode over here. Now I have copper. I have pure copper here. So I can use the wow, losing my voice. I can use that as my metal in this case. So this is going to be my copper ion here, or my copper, not ion, but my copper metal. Okay, so I've got my copper metal here. I'm going to have that in a solution here that is something like copper 2+ solution. And let's say that we've got in that we have our, you know, a nitrate or something in here. Okay, so we can put in like a nitrate ion of some sort to balance out that charge. I want to put one more copper in here, Cu2+. Okay, so I've got my anode set up. Now I need to go over here and I need to do my cathode. My cathode, when I set this up, I can't use, I have iron 3 and iron 2. This has to be a pure metal in here or a pure thing. Okay, so I can't put iron 2 or iron 3 in here because that doesn't work. I would have to have iron without a charge on it, and I can't do that. So I'm going to use, let's use platinum here. Okay, platinum doesn't react with stuff really. It's just going to be a thing that the electrons can travel through and change stuff over here. Okay, so I'm going to start out over here. I'm going to have my iron 3. Yeah, it's picking up iron. Yeah, this is going to be iron 3 here. Iron 3 here, and I'll show you here why I picked that in just a second. Okay, so this is my iron 3. This is my iron 3 on here. Okay, and I picked it because of this. Okay, this is my platinum, and I've got my iron 3 in here. I'm also going to have some sort of negative ion in there to balance that out as well. Okay, so let's just throw some nitrate in here. Good? All right, everybody up with me on that? Now, I'm going to take a wire, and typically you'll have like a voltmeter here, or you'll have a load like a you know, a cell phone or something, your car, alternator or whatever it is. I don't know car parts, so don't ask me. Let's say that we have a voltmeter here. That voltmeter is going to read 0.43 volts. Okay, so we've got that. This is what our electrons are going to travel on. Now, because I set this up with anode over here and cathode over here, I always know that my electrons are going to flow this direction. Okay, and if you think about it, they're going to flow from the copper. Okay, I'm producing the electrons. It's going to go across here, and it's going to get picked up by this iron. Okay, So it flows from the anode to the cathode. And when I design these, and I have my anode over here, I always know that it's going that direction. But they may have this already set up for you, so you've still got to be able to figure that out on your own. Okay? But it flows from the anode to the cathode. All right. What's going to happen is you are going to take one of these coppers. Okay, so one of these coppers is going to give off 2 electrons, and it's going to go into this. Okay, so I'm going to take one of these coppers. It's going to produce these 2 electrons. Down here, actually, I'm going to make this red just so that you can see that that brought it in. Down here, this is a copper 2+. So I have disrupted the charge in this section now because I have added in a 2+ ion. What has also happened to the size of this material? It's gone down by an atom. And if you keep going down by an atom, and this can't stop. If you keep going down by atoms, this is going to get smaller. Okay? So this is going to go across, and these electrons are going to come over here. We're going to come back and deal with that charge in just a minute, because I have forgotten a component. I haven't forgotten. I've intentionally neglected a component here that we're going to bring in just a second, and we're going to talk about how we deal with that charge. Okay? So I'm going to bring these 2 electrons over. They're going to travel down here. So I've got an electron coming in here. That electron is going to hook up with this guy. Okay? And he's not going to be Fe3 anymore. Now, all of a sudden, he's going to turn into Fe2+, because he picked up that electron right there. Okay, that electron traveled across, he picked it up, and he became this. Then this guy is going to do the same thing. He's going to pick up this electron. He's not going to be Fe3 anymore. He's going to be Fe2+. Okay, but this has become more negative. That's a problem. Okay, this is increased by 2 negative values over here. This is increased by 2 positive values. So now we've got imbalance in charge in both of these areas. So what we do to deal with that is we create something called a salt bridge. Okay, so we are going to create a system here. And when they ask you to create this, you always want to create it using a neutral salt. Okay, now let's go back and talk about, again, what a neutral salt is. Okay, this is my salt bridge that I have built. A neutral salt, remember, is when it is placed in water, it won't change the pH. Okay, it is going to consist of an anion of a strong base and a cation, so we could use chlorine here even, of a strong acid. So cation of a strong base and an anion of a strong acid. So let's say that we have a sodium chloride salt bridge set up here. These are in their ion forms. This increased by 2+ in here. I need to neutralize that. So that needs to get what? To neutralize this, I need what kind of charge?
2 chlorine.
Right, 2 negatives. Okay. So this chlorine here, I don't know if this is going to let me erase. No, it didn't. Shoot. I I lost my salt bridge. All right. I was afraid that would happen. All right. So this chlorine is going to go and travel down here. And this chlorine is going to go travel down into here. And that's going to negate that 2 plus. Okay. Over here, I have this increasing by 2 negative charges. So now we're going to take 2 of these sodiums, and they're going to come in here, and they will then neutralize this value. Does that make sense? So we're balancing charge. Everybody cool with my galvanic cell? It's kind of ugly, but you get the idea, right? Okay. All right. And I got to grade her test because she's going to get really mad at me. Well, she said she has tennis, so I'm just going to ignore this thing for a little bit longer because I hate grading papers. There. Yeah, so I can put it off till Friday. All right, let's see here. Nope, that's not the document. This is the document. There's, you know, out of all the things that I hate doing, teaching, grading papers is the thing. I just have never enjoyed that at all. All right, exercise 2. Let's go through, see if you guys can draw this. See if you can figure out your cell voltage. See if you can, so we've got silver now, we've got iron. It's going from iron 2 to iron 3, so you're going to need platinum in there, or you can use graphite. But those would be options that you could use. See if you can figure out your voltage. Oh, goodness. And you have to figure out your... you able to figure out which one of these was going to be reduced and which one of these was going to be oxidized? Okay. This one's going to be reduced because this is more positive. So this is where our reduction is going to happen. It also told us that we were going from Fe2 plus to Fe3 plus. So we know that we're going to be losing an electron here when this happens. Okay? So if this is losing electrons, that's another way that we can identify that this one's going to be oxidized, and this is going to be our anode. Which means that this is going to gain an electron. So this is going to be Ag. This is going to be our Ag plus is going to become Ag then. Does that make sense? Okay. And this is going to be reduced. This is going to be our cathode. So if I do cathode minus anode, my cathode is 0.8. I'm going to minus a 0.77. That's going to give me a 0.03 volt for my answer here for how much I'm going to lose, or how much voltage is going to come out of this. Not a lot of voltage, by the way. All right, questions on that? How I figured out my reduction, my... Okay. So then when I go to draw my galvanic cell here, it's going to be 0.03 volts. I'm going to give myself a little bit of room to work here. They didn't specify anything in the salt bridge or anything specific like that. So I'm going to draw my anode over here. I'm going to draw my cathode over here. Do you guys need more time drawing these things? This is going to be my anode. Since this is not a pure metal here, I'm going to have to use something like platinum or graphite for my metal, for my anode. Over here, this is pure metal, so I can use silver over here if I can afford it. Okay, and I'm going to have my material in here. All right, in here is going to then be my Fe2 plus. And over here, I'm going to have my Ag plus, and then I'll have some sort of negative ion in here to balance that out. Let's say NO3. It needs to be from salt that is not going to cause any kind of imbalance as far as acids or bases. Okay? I'm going to have a wire. That wire is going to connect up. I'm going to have a voltmeter here. And they will sometimes ask you to write in the voltmeter what that voltage would be. And this is how we do that. Oh, the other thing that we needed to make sure of was that our electrons, everything balanced here. What would my N value be for this guy? 1. 1 mole of electrons. And my electrons are going to come across this wire. They will sometimes ask you which way the electrons will travel. They always travel from the anode to the cathode. This is my cathode. We know that because this is being reduced. Okay. Now, how is that going to happen? Well, this guy is going to go over. He's going to hit this platinum. When he hits this platinum, he's going to give up one of his electrons. That electron's going to go across here. He's going to, by giving up an electron, he is then going to change from Fe2 plus to Fe3 plus. Okay, so his charge is going to change to a 3 plus here by giving up that electron. So here's my electron that came off. and he's going to travel across here. Okay, that's going to happen with another Fe3+, and so forth and so on. That electron then is going to come across here. Oh, why is this not working out right? Oh, yeah, this works out right. The electron comes across here. It's going to grab a hold of one of these with the electron, and we're going to start depositing, and we're going to start adding silver onto this. Okay, so this is actually going to start getting bigger and bigger and bigger as we're adding more and more electrons. We're depositing silver ions, becoming silver atoms onto here. Okay, that's why they call this a fat cat, because he's going to get bigger. The cathode gets bigger.
Is that the electroplate stuff?
That is coming up. Okay, electroplating, they actually have to add a that's like a reverse kind of thing. So they actually have to add energy in to make it happen. This will happen naturally on its own. Okay, so here, when we want this to happen, all we have to do is hook up these wires, and boom, it just goes. Okay, electroplating is kind of the reverse. We have to add energy in, because what happens here is your anode and your cathode. This cathode that you want to be a cathode actually has, you'll end up with a negative value for this. And so in order to force that the other direction, you got to add energy in. And that's how they electroplate stuff, is they essentially reverse this whole around. All right. But when we're pulling these positives out, our negative charge is building up. So we got to make sure that we have a salt bridge in here that is maintaining that charge. Okay. So as we are increasing our positives over here, we have to bring in something from that salt bridge, like chlorine ions, direction this way to match up with this positive charge to balance that out. And something like sodium needs to come over here because we're pulling positive charges out over onto the metal. So we've got to bring a positive charge in here. And they'll oftentimes say, like, you know, we've drawn your salt bridge in here with sodium and chlorine. You know, you need to draw which way the chlorine's going to go and which way the sodium's going to go. Because if they just have this up here without any arrows, you've got to figure out, you got to look at this thing and go, oh, yeah, the positives are going this direction, the negatives are going to go this direction. It's logic. You know, that I've told you that from day one in here. A quarter of AP Chem is just sheer logic.
When they write it though, are they gonna have like the anode?
Not necessarily. No. I'm just saying when I draw it, that's the way I draw it. But no, they could easily have them.
Will they at least give you the direction of it?
Nope. You have to know that they flow from the anode to the cathode.
But they won't give you the end of the cathode?
You have to figure it out. You can figure that out by looking here. This is a more positive value than this. This is your cathode.
So I'll have the voltage.
Mm-hmm. Yeah, you would never have to memorize these.
I didn't know if they're gonna like make this like they're just gonna like fill in the molecules.
You might have. They might have to have you. They might make you calculate these.
But then you work for that?
Mm-hmm. We also learned back in, I think, a previous note packet, how to calculate these E. Yeah. So when we looked at, let's see if I can find. This one, yeah, here. So we figured out in here how to calculate E prime. Didn't we? Yeah, no, not that one. Yeah, here. No. Where do we calculate? I know we calculate.
Please excuse this interruption for brief announcement. Hey, seniors, you may have heard that there will be a prom on May 1st. In addition to the traditional junior court, we will also be having a senior court. It's time to vote for your prom court, seniors. Please look in your senior class Google Classroom for a form to vote. Please only vote once. Voting will close on April 14th at 11:59 p.m. Get your vote in, seniors, make them count. Thank you, Ms. Duncan and Ms. Hanson, for your efforts to make prom happen this year. Thank you.
So, I have a question, because you run homecoming, right?
Mm-hmm.
So if you,
I don't run homecoming. I run homecoming court.
court, that's what I meant. So if you are on prom court, you can't be on homecoming court the next year.
Correct.
If you run for it, you don't make it on prom court, can you still run the next year for homecoming?
Yes. So here, you are going to eventually be figuring out E prime, okay? So you may have to use this, like, information here to be able to figure out, you know, voltage for this. Okay, so that's coming. I was thinking we'd already covered it, but we haven't. So all of that is coming. But you should be able to, in your sleep, build one of these galvanic cells now. Okay? Did we finish that up? Yes, I think that's where we just did this one, right? The silver?
Yep.
Okay, so we're done. We're putting galvanic cells to bed. We are done with them. Tomorrow we are starting this. You need to be able to, in your homework, you should be able to do, I think it's 9-6 now. Or 9-7. 9-7. Yeah, 9-7, you should be able to do that tonight. And then keep working on your final exam stuff.
Can you use NaCl for like every cell bridge or like no?
Yeah, I would. Like I said, you can use potassium nitrate. Just make sure that you're using something that's a neutral salt.
I was just wondering because that was like the easiest, like,
Yep.
so I didn't know if it's gonna like change.
No, and they'll probably have a lot of that sort of thing set up, like a salt bridge. They'll probably already have set up for you. You just have to tell them like which direction things go. I doubt that they would make you draw a whole galvanic cell on there. But the point is that if you can draw it, then you can do any part of it. You know.
You know,
All right.
this class I'm like more prepared for the AP test than.
Huh?
This class is like my top class I'm prepared for the AP test.
Well, I should stop this before I say anything.
Yeah, I know. But like I like how like you still made like